This is the finale, and it does two things. First, we design one more system, trending now, ranking the hottest titles in the real time out of a fire hose of the play events. Then we do the payoff the whole series has been building towards. We take all the 4 episodes and assemble them into a single complete Netflix backend, live on one diagram. Let's finish this. Design Netflix episode 4, the last one, trending now in real time, with a count min sketch, and then the whole system on a single diagram. So welcome back one last time. 3 episodes down. Continue watching, stream limits, press play. Today episode 4, trending now, and the mega diagram. You'll learn how to rank the top 10 out of 50,000 titles at a million events a second, using a data structure that fits in the few megabytes no matter how much you throw at it. And then watch every piece you have built snap into one picture. Let's finish this. Let's define the problem precisely, because trending hides some teeth. The trending now row is that strip of what's hot right this minute. A show that drops 3 hours ago rocketing up. Yesterday's number 1 sliding down. A viral clip pulling its whole series up with it. Now the scale. It's fed by the same fire hose from episode 1. Around a million play events a second. From that, you need the top 10 or 20 out of a catalog of roughly 50,000 titles. And people expect it fresh within minutes, not days. So here's the real question, and it's a sharper than it looks. How do you rank top 10 out of 50,000 from a fire hose without counting everything exact to see? Because as we are about to see, counting everything exactly is precisely what breaks. The obvious answer is count head. So let's build that in our heads and watch it fall over, because the way it fails tells us what to build instead. Attempt 1 row per title, and every play does a +1. At a million plays a second, 2 problems hit at once. First, the trending drama is getting a massive share of all those rights, all landing on one key. That's a textbook hot partition meltdown, the exact thing we spent episode 1 avoiding. And second, to actually produce the top 10, you would have to sort 50,000 titles on every refresh. Hotkeys plus a full sort. No. Attempt 2. Forget the database. Keep every count in one big in-memory hash map. And for 50,000 titles, honestly that's fine, it fits. But then interviewer asks the question they always ask. Now do it per country and per hour, or maybe per device type. Suddenly your key space isn't 50,000. It's titles times countries times hours times devices. Billions of combinations, and exact memory grows along with it. You would be spending gigabytes of RAM to hold counts precisely to the single play for a row where nobody will ever notice if it's slightly off. And that last thought is the whole unlock. Nobody audits trending now. If number 4 and number 5 swaps for a minute, not one person on earth complains. So we can trade a little accuracy for a huge cut in memory. This looks like exact counting problem, but it's an approximate one, wearing the exact costume. And there's a gorgeous data structure built for exactly that. Let's spin the requirements, because every one of them is going to give us permission to do something cheaper. Functionally, 1. Rank the top 10 to 20 titles by play volume, and reuse the exact same event stream from episode 1, so there is no new client work. 2. Over a sliding time window. Trending means the last few hours, not all the time. A hit from 2019 shouldn't camp at number 1 forever. 3. Sliceable. Global, per country, maybe per device, which is exactly the cardinality trap that just killed the exact counting. Now the non-functionals. And this is where we get the gifts. Freshness in minutes, not milliseconds. Trending is a vibe, not a stock ticker. And that single relaxation loosens the entire pipeline. Approximate is acceptable. Ranking roughly right is fine. Exact counts are vested precision here. Memory must stay bounded. Cost has to stay flat as titles and slices grow, ideally independent of cardinality entirely. And reads are free and global. Millions of people load this row, so it has to be pre-computed cache hit. Same read patterns as episode 1 and 3. Here's the mindset I want you to carry with this one. In a design system interview, every relaxation is a gift. Approximate, minute, fresh, no audit. Those 3 words are permissions to reach for a probabilistic data structure and stream processing. The exact same tools would be reckless for episodes 2 stream counter, where a wrong answer is an oversell. Right tool, right flow. So let me teach you a count min sketch, because it's one of those ideas that feels like magic until you see it, and then it feels obvious. Picture a small grid, say 4 rows, and a few thousand columns per row. Just a fixed block of counters, a few megabytes total, and we pick 4 independent hash functions, 1 per row. Now a play event comes in for, say, Stranger's Thing. We run the title through hash function 1, it points at some column in row 1, and we add 1 to that cell. Hash 2 points at a different column in row 2, add 1 there. Hash 3, row 3, add 1. hash 4, row 4 at 1. That's the entire write. A title comes in, we bump one cell in each row, no hotkey because the load is scattered across the whole grid by design. Now, how do you read a count back? You hash the title again, look at those same 4 cells and you take the minimum of them. Say the 4 cell read 42, 40, 47, 41. Your estimate is 40, the smallest. And here's a clever bit. The reason it's called count min. Different titles can hash the same cell. So a cell can be shared, which means a count can be inflated by collisions, but it can never be too low. Every cell that holds your title holds at least your true count. So the smallest of the 4 has suffered the fewest collisions and is closest to the truth. You always take the min because the min is the least polluted estimate. 3 properties make this a perfect fit. 1. Writes just jump a few cells. No hot partition ever. 2. Collisions only ever add, never subtract. So you might rank a title slightly high, but you will never miss a genuinely huge one, which is exactly the failure mode you can tolerate for trending. And 3. The big one. The memory is fixed, width times depth, a few megabytes. Whether you are tracking 50,000 titles or 5 million country or device combinations. Cardinality simply stops mattering. That's the property that killed both our native attempts, handed to us for free. Reads are constant time too. Hash, take them in, and done. Now the sketch is brilliant, but it has one blind stop. The naming it leads to the rest of the design. The sketch answers how many plays for title X cheaply, but it cannot tell you who the top titles even are and has no list of titles inside it. Just a grid of numbers. Ask it who is the number 1 and it has nothing. So we pair it with a second structure, a min-heap of size k, say 20. As events flow, we keep the current top 20 in the heap. New titles estimate beats the smallest one in the heap, swap it in, evict the minimum. The heap is tiny 20 entries and it's always holding the current leaders. Sketch does the counting, heap does the ranking. 2 simple structures, each doing the one thing it's good at. Then every minute or so, we snapshot the heap. Just dump those 20 titles into a pre-computed top K list in EV cache. And now read path is identical to episode 1 and 3. The home screen just reads a tiny cache list. All the heavy lifting happened upstream asynchronously. Fold on write one more time. Last piece. What makes it trending and not all-time popular is the time window, and there is a really clean way to do it. Instead of one sketch, keep several small ones, one per 5-minute bucket. To get the last few hours, you sum the recent buckets, and when the bucket edges out, you just drop it. That's the elegant part. Old counts fall off automatically, so the numbers naturally decay. Yesterday's number 1 fades on its own. No one deletes to run or decay math to tune. The window does the forgetting for you. Let's wire it in architecture. And the beautiful thing is how little is new. We already have the play event stream in Kafka from episode 1. Trending is just a new consumer group on the end of it. Same events, we are only adding a new reader. That reader is a flink job, a trending job. Per event, it bumps the countment sketch, maintains the sliding window buckets, keeps the size k heap, and emit a top k snapshot every minute. The snapshot lands in EV cache, globally replicated, and GraphQL Edge serves the trending now row from there. Now one subtle interview gold detail, the partition key. In episode 1, we keyed Kafka by member ID to get per member ordering for continue watching. For trending, we are rekeying by title ID so that every play of a given title lands on the same flink task and can be aggregated cleanly. Same pattern, but you read it through a different lens depending on the job. Being able to say that out loud shows you actually understand what partitioning buys you. The reside you already know cold. A device asks a GraphQL Edge for trending now row. It's a cache hit of that pre-computed list sub-milliseconds. And notice, reads never touch flink or the sketch. The expensive stream computation runs async out of band and the home screen just reads a tiny finished list. That's a fold on write for the 4th time in this series. Do the work once on the way in, so a million readers each pay almost nothing. If you only remember one pattern from all 4 episodes, make it this one. Okay, trending is done, and that was the last new system. So now let's zoom all the way out, because here is the thing I have been hinting at since episode 1. These were never 4 separate designs, they were 4 layers of one machine. Episode 1, continue watching, gave us the spine, Kafka, Flink, Cassandra and the EV cache read path, the write and read backbone. Episode 2, stream limits, added a consistency gate on site, the session service, Redis, atomic reserves, leases. Episode 3, press play, added the entire delivery plane, the playback orchestrator, DRM, steering, and OpenConnect. And episode 4, trending, hung on analytics fan out of the existing event string. And here is why they compose so cleanly. They share the same edge, Zool, and GraphQL, the same event stream in Kafka, and the same cache first read pattern. So they don't just sit next to each other, they interlock. Watch them snap into one diagram. Here it is, the whole system on one canvas. I'll build it in layers. Follow the colors. Top band in teal is the control plane read path on AWS. A client hits Zool, our edge, authentication rate limiting, load shedding. Zool hands off to the GraphQL Federation router, which plans the query and calls the DGS subgraphs, playback, member, and now trending. Those reads through EV cache a millisecond, globally replicated, and only on a miss do they drop to Cassandra, our source of truth, with its live VH and compressed VH tiers. Off the side, the schema registry keeps all those subgraphs composable. That's episode 1's read path, still the backbone. Bottom left hand in amber is async pipeline. Playback events pour from Zool into the ingest service, a fast 202 into Kafka. And now Kafka fans out to two consumers, the episode 1 fling job that folds events into the continue watching state in Cassandra, and the episode 4 fling job running our count, min, sketch, and heap, snapshotting top K into cache. One stream, two lenses, keyed by member for one, by title for the other. Over on the left in magenta sits episode 2's consistency gate, the session service and the atomic Redis counter, the one strongly consistent island in an otherwise eventual system. And the right band, the data plane, episode 3, the playback service calls steering and DRM, gets a ranked list of OpenConnect caches, and then the one heavy arrow on the whole board, encrypted video segments streaming from an OCA inside your ISP, straight to the player, never through AWS. 4 colors, 4 episodes, 1 machine. That's Netflix core, and you just built every layer of it. A diagram this busy can overwhelm. So here's a trick to actually holding it in your head and to presenting it. Don't memorize the boxes. Trace 3 journeys. Journey 1, a read, loading the home screen, client to Zool, to GraphQL router, to a DGS, to EV cache. And only on a miss, Cassandra. Cache first, about 150 milliseconds. That single path lights up continue watching and trending. Journey 2, a write, a playback event. Client Zool ingest returns a 202 into Kafka, consumed by Flink, both the state job and the trending job, landing in Cassandra and the top K cache. Accept fast, process async. Journey 3, the video itself. Client to playback service, which calls steering and DRM, which handback ranked caches, and then bytes flow from OpenConnect inside your ISP back to the client. 100% of traffic and never touches the cloud. Read, write, video. 3 stories. If you can walk in an interview through those 3 journeys on a whiteboard, you have demonstrated the entire system without memorizing a thing. Because each journey is just a sentence, and the diagram is only the 3 sentences drawn on top of each other. That's how you make a system this size feel simple. Now step back one more level. About the boxes to the ideas, because the same handful of the patterns showed up in every single episode, just wearing different costumes. Idempotency, episode 1. A client minted event ID dedupe playback events. Episode 2. The account device paired dedupe reservations. Episode 3. A retry safe start call. Episode 4. Replayable Kafka offsets. At least once delivery plus idempotent handling everywhere. Fold on right, the continue watching row, the live stream counter, and the pre-encoded bitrate ladder, the top K snapshot, all pre-computed so reads can stay cheap. Consistency chosen per flow, eventual for resume points, strong for stream slots, and a hard gate for DRM, approximate for trending. 4 different answers, each said out loud in one product. Cache the read. EV cache carried a resume point, the cache plan limit, and the top K list. And OpenConnect is really just the same idea taken to a physical extreme. A cache the size of a data center sitting on your ISP. And degrade never fails. A stale row failing open on a counter, dropping bitrate, serving the last good snapshot. Every layer gives up quality before it gives up availability. 5 patterns, learn these deeply, and you are not memorizing Netflix. You are carrying a toolkit into any system design problem that can throw at you. The specifics are disposable. The patterns are the point. Last thing, and it might be the most important, because a perfect diagram with a bad delivery still fails the interview. The diagram isn't the score, driving it is. Here's the shape of the 45-minute session. First 5 minutes, scope and numbers. Nail the requirements, do the one calculation that forces the design, and announce your plan out loud so the interviewer can follow you. Next 10, API and data model. The contract, the schema, because everything downstream hangs off that shape. Then 10 on the high level design, boxes and the happy path, kept clean. Depth comes next. The final 20 on the deep dives and failure mode. That's where the interview is actually won. So budget the most time there. And 3 habits that read as staff in any room. Numbers before choices. Never name Cassandra or accountment sketch until the math forces your hand. Let the estimate justify the tool. Name the trade-offs before you ask. I am choosing availability here because the stale row is invisible but an error page isn't. That one sentence is the cleanest seniority signal there is. And volunteer the failure modes. For each box, say what breaks, the blast radius, the fallback, and what you would alert on without waiting to be prompted. Do these 3 things, levels are taken care of itself. So that's the series. Look at what you built. Continue watching. The right spine, fold on right, and AP store chosen on purpose. Stream limits, atomic reserves, leases, failing open. Press play, the control plane and data plane split, a CDN living inside your ISP. And trending now, a count sketch, a heap, and a mega diagram that tied it all together. 4 episodes, 1 backend, and you drove every layer. If you want to go deeper, the next series on the channel is a staff system design patterns. The reusable building blocks underneath designs exactly like this one pattern at a time. Subscribe and it will find you. Tell me in the comments which episode clicked hardest and what should be the redesign next. I read every one and your suggestions might be the next series. Thank you for watching the whole thing. It genuinely means a lot. See you in the next one.